For this example, what we're going to do is we're going to combine like radicals. Problem is, taking a look at them, none of them are like. However, we can fix that by turning them into mixed radicals. Let's start with A. So root 20 can be broken down to 4 times 5. This 4 right here is a perfect square. We can bring it out. So this is now going to be 2 root 5. Root 18, that can be broken down to 9 times 2, with 9 being the perfect square. This is going to leave you with 3 root 2. Root 80 is going to be 16 times 5. With the 16 being brought out, that's going to leave you with 4 root 5. And last but not least, we've got root 98. That can be broken down to 49 times 2. The 49 can be brought out. That's going to leave you with 7 root 2. Now you notice we have like radicals because the radicands are the same. I'm going to highlight them. Ones with the 5 radicand are green. The ones with the 2 radicand are the ones I'm highlighting in pink. Right? So you only collect those that are like. So for 2 root 5 minus 4 root 5, that's going to give you negative 2 root 5. I'm going to cross them out as I do them. After that, we got 3 root 2 plus 7 root 2. Adding those together, you have 10 root 2. Now you notice I did not do anything to the radicands. You leave those alone, and you can't go any further than this because the radicands are different. For B, you can actually break this down further, even though they do look like mixed radicals. So let's take a look at that. We've got 3 root 28. Well, 28 can be broken down to 4 times 7. That 4 is a perfect square. You can bring that out, and now you're going to take that and multiply that by 3. For the next one, you have negative 1/2 times by root 128. That 128 can be broken down to 64 times 2. 64 is perfect square. That can be brought out. That's going to be 8 times 1/2. Next up, we have 2 root 175. That can be broken down to 25 times by 7. 25 is a perfect square. Bring that out. Now it's 5 times that 2 on the outside. And last but not least, you have 2 root 63. That's going to be 9 times 7. That 9 is a perfect square. That can be brought out, and now it's 3. 3 times 2. Alright, working these ones out. The first one is going to be 6 root 7. This one right here, if it helps anything, you can always put that 8 over a 1. We're going to be multiplying 8 times 1/2. The 8 and the 2 get crossed out, so now you have 4 and 1. So that's going to be 4 root 2 as a result. After that, you've got 5 times 2 on the outside. That's going to be 10 root 7. That's what this one was here before. And after that, last one is 2 root 63. That can be broken down to 6 root 7 because we multiplied the 3 and the 2 together. Here's a common radicand with this one, and this one right here is all by itself. Okay, so all you need to do here is collect your like terms. So you get 6 root 7 minus 10 root 7 plus 6 root 7. So 6 root 7 minus 10 root 7, that's going to be negative 4 root 7, and that's going to be plus 6 root 7. So your final answer for that collection is going to be 2 root 7. After that, we have just the negative 4 root 2. And we can't go any further because, again, the radicands are different. So this right here is going to be your final answer.